How you doing?
Hey, pretty good,
Hi.
pretty good. How are you guys?
We're
Uh, so
doing good.
excellent, excellent. So yeah, I was just reviewing all of these videos the other day and everything, and I think I have some theoretical that I want to share with you. Let me show you if I can share my screen.
Yeah, yeah. Feel
Okay.
free.
This actually I did with the help of the artificial intelligence. So let me show you. The first thing that we need to check is the law of Faraday. So, Lady Faraday, Lady Faraday. So you guys are familiar with this one? Uh, law of Faraday. Are you guys familiar with it or no?
Yeah, yeah.
Yes, yes, yes.
Okay. So it talks about the tension that will be induced by a magnetic field that is changing in time. Right. This is what this is saying. So this is saying the voltage, which is this epsilon, is going to be equal to minus n, which is the number of turns of the coil, I think. And then this one on top is the difference in the magnetic field, and the one below is the difference in time. So I was checking this one the other day, and if you see what happens if you make the time really small, see, so the this delta t, what happens if we make it super small? You guys know?
How they? No. Explain it to us.
Okay, let me show you. This is okay. uh, well, basically what we have to do is you cannot obviously make this zero because okay, let's do something. Actually, I'm gonna show you. This was my process of thought the other day. Let me show you. So say that we have the coil, right? We have the coil here. I'm gonna draw the coil. So we have the coil, and then we have negative this side, and we have positive this side.
Hmm.
And so what you have guys have been saying, right? So if you open the switch first you close the switch, and there will be differential. Let's say that we are applying 12 volts here. So the current will start to flow, right, from positive to negative. It's gonna keep going, flowing
Okay.
flowing through the coil, right?
Right.
And then what this is gonna happen is gonna create the magnetic field, right, which is gonna be opening up like this, right?
Right.
And then what happens if you just cut the current, cut the difference in potential? You cut it all of the sudden. So there is no differential in potential anymore. So the current cannot flow anymore, basically, because the resistance of the circuit, when you cut the flow, it's going to become infinite resistance. There will be no flow at all, right? Wh- Do you
Right.
agree to
Right.
that? Right?
Yeah. Yeah.
So still the magnetic field is still exists at that point in time because it did not go anywhere. It's not like it's gonna instantly disappear. So theoretically, it can it can disappear. Like, well, theoretically, what is gonna happen is that um, it should disappear, right? It should disappear. It should go away. That's in theory, but in reality, it seems like that's not happening. And what's happening is that the energy, the magnetic field is collapsing towards the coil like this,
Yeah.
right?
You're talking about back EMF.
Exactly, by KMF. and that's going to induce a current in this coil, but in the other way. Like the current is going to flow into this way. So when that happens, if this was a physical switch, there can be an arc right here generated to discharge the energy that was left stored in the coil,
Right.
right? So uh, this is when you look at the formula, it's saying that it's going to be the difference between the rate of change of the magnetic field against the time. So if we look at this example, at what time or at what velocity, how much time is going to take this to to move this distance? Let's say that it's maybe, I don't know, 5 inches over here. So how much time will the magnetic field is going to reach the coil, right?
Right.
How long is it going to take to collapse? That's the question. Like, how long is it going to take to collapse? So because it's collapsing at the speed of light, this time becomes really, 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 really super small, because the magnetic field is collapsing at the speed of light, right?
Okay.
So let me show you this. I'm gonna show you my DeepSeek chat, because the other day I was just asking this question.
I don't believe it's collapsing at the speed of light, but it is collapsing really fast.
Exactly, exactly. It is the if I'm not mistaken, what is keeping it from collapsing at the speed of light is that the speed of light has a certain speed in the air, for example. Like, it's not the same as in the vacuum, right?
Right.
Right.
Electrons don't move at the speed of light, so.
Ex- yes, that also, that also. So right here, I'm asking, at what speed is the magnetic field going to collapse, assuming there is a coil, a copper coil, connected to a switch that is opening. That's my question. Okay, and this is throwing this theoretical analysis right here. So this is what I'm saying. Theoretical instantaneous collapse. In an ideal scenario with no resistance or capacitance, the magnetic field will collapse instantly as the current stops. However, this is unphysically due to infinite voltage spikes. What we were talking about, it cannot be infinite. It cannot be zero. dt cannot be zero because it's dividing, right?
Right. Right.
It has to be a very, very minimal value, but it cannot be zero. So
Exactly.
this is what if you take a look at this, um, in this example, it's saying that the voltage is going to go so high that the air will become a conductor at 3000 volts, right?
Yep.
And at that time, the spark will be discharged into the air and into the ground, and that's going to happen. In this example, it's going to happen in 33 microseconds with a given coil of 1 Henry of inductance, and given an initial amperage of 1 amp. So look at my next question. In the previous example, you're telling me that there during this instance there was a generation of 3000 watts, because it was 3000 volts, 1 amp, right? Which is 3000 watts.
Okay.
Okay.
I'm trying to make my screen a little bit bigger.
Oh yeah, let me try to make it bigger here. So see how in this example, because the air is breaking at 3000 volts, during that time, there was a voltage spike and a power
Right.
spike of 3,000 watts. So look at what this is telling me. This is telling me you are correct in noting that 3 kilowatts was producing 3,000 watts, but this represents the instantaneous power dissipated during the collapse of the magnetic field, not the total energy or the sustained power. Here's a
Right.
breakdown of the physics. So here's going to tell us why this is not breaking the laws of physics. As you can see here, this is the energy stored in the coil. This is the energy stored in the coil. If there is 1 amp of current going through the coil, it's
Yeah.
only 5.05 joules. So that's really, really few energy. Okay, but look at this instantaneous power during release. Okay, 3,000 volts, 1 amp, 3,000 watts. Okay, but look at this average power equals to amount of energy released between the amount of time that it took you. And because the amount of time that is taking you is so few, this is why it's giving us in this case the average one is giving us 1,500, and the max power is going to give us 3,000 watts. So this means that this 5 joules of energy was released in only 333 microseconds. So remember the definition of power. If we look at the average power definition, average power formula, average power is equals to amount of work done between amount of time taken. So this is another formula in which if you make the time really few, like a really small amount of time, the power is going to be greater.
And yeah, you talking about frequency now or hertz.
Yes, because this is only you could say it's only one crest of the sine wave, right? Because in
Right.
the sine wave there will be basically because we only tap the switch once, we're only generating like one single pulse. So this is just
Yes.
one, yeah, this is just one arc basically. And so yeah, this is what I wanted to show you because it's telling me this, and then at some point it actually tell me that see, at no point did I ask anything about infinite energy, 0 point energy, or whatever. And she's telling me, oh, but beware, this is not infinite energy. The coil's energy is finite and safely dissipated through the arc. So what it's trying to tell us is that somehow this is not free energy. We know that this is not free energy, but it's because the energy is being released in such a small amount of time that the
What what
power is so great.
what is your definition of free energy?
Well, I mean, it's not like we are creating energy out of nothing because you needed to start with the 5 joules.
Right. And I agree with that. But my definition of free energy is energy you don't pay for.
Yes, that's right.
Okay. So again, people have different ideas on what free energy is, and all these definitions people have. One of the biggest thing that I argue with, and I talk to a lot of different types of AI. Google is more stringent, and so me and the AI is having a discussion on what is over unity. I take over unity from the dictionary, okay? And it's taking over unity from people who are what they consider pseudoscience. But as soon as you start to ask AI if the people you're taking this definition from is pseudoscience and you're saying that their science is wrong, why are you trying to make that into a definition when you already have definitions for the very word that are correct? Why would you say now this word over unity and these words already existed before they changed it? Why are you now changing it to something you say is incorrect? And it couldn't answer that question. He says it sees my argument, but this is what is acceptable for today. So, we got a lot of people who say that a man can be a woman and a woman can be a man. You had people who thought they were Superman and jumped out of off the roofs and out of windows and stuff. So, the results of that. A woman is a woman, a man is a man, and we can't fly. So when you start to look at the base thing, you start to see that everybody uses these terminology traps to keep us ignorant to the fact we can do more than what we say. So if you're taking your example and you have three coils in there, and those coils are going to separate items, and I start pushing my magnet back and forth to get the electrons to move, then are that energy going to those three different items, or is it only going to one item? Since all these coils are wrapped right on top of each other. Do you understand my example?
Right, right, right.
Right. So the whole point is that you can manage energy by doing multiple things with the energy that you're supplying from the magnet. So if the magnet is inducing the electrons to move, and now it's actually getting that amps and volts out of that coil, then when you have more than one coil going to more than one thing, you're splitting up the power. And all electronics are like this. That means that we can manage energy, and Nikola Tesla did this when he did his motor, and when he had his three-phase motors. Those wires are overlapping each other, and yes, he can do more than one thing. And the example that you gives that example that, yeah, if you're overlapping energy and you're getting it to do something separate than what it was originally doing, it is quite possible. The math you just showed does show that it is quite possible to have phased energy.
Yeah, definitely. It is absolutely possible. Yeah, yeah.
Yeah,
The only thing that they're saying is that it's impossible to harvest or whatever, but I mean, I think we need to work like in the engineering to harvest it, right? Like,
yeah.
yeah,
But we're not saying that we're getting more power out. We're just saying that we're managing energy between two circuits. So you can have two different circuits doing two different things, and still it just splits the energy. That means that they're not getting the full benefit, but it's still in a positive range. So yeah, you can
yeah,
split energy. You
yeah.
know,
We just made a demonstration that it's not violating the laws of physics. Like,
yes.
it's not the same. Like, for example, if I move my car, if I push it 1 meter, I spend 500 watts. But it's depends on the time that I did it. If I did it in 5 seconds, maybe I spend the 500 watts. But if I did it in 5 microseconds, then I did it with 30,000 watts, or I don't know, whatever. But we're not violating the laws of physics. We're just distributing the energy, as you mentioned, like in a faster way, in a more efficient manner.
Yeah, you
Yeah.
know that a chart a a charge pump does the same thing. You have two capacitors. If you attach them together and you pulse it really fast, you get double the voltage out. And they call it a voltage doubler or a charge pump. They have different names for it. But if you have one capacitor and you're doing the same thing, you're just getting the same energy out. But if you split it between the two and you ask the question, how am I getting double the energy out? And because both of them are contributing energy, but they're alternating. And this is what Nikolai Tesla is all everybody has been talking about, how you can overlap something. So if you wanted to put it in an example, if you took a string and attach it to a magnet, and every time you pulse that magnet, the string would move. You would see a wave go down to the end that has a post. Now that wave, once it hits that little anchor or post that you have it to, will bounce back and you'll see the wave coming back. Now, if you don't put any more energy on there, it the wave stops. But when you pulse it at the exact time that the wave hits the magnet again, it doubles the wave. Okay. And if you keep doing that, okay. So this is what we talked about, synchronizing energy. And this is what Nikolai also talk about scalar waves and how you can actually scale these waves up from just the same energy that you're applying into it. And it's, if people don't understand the technical terms that I'm saying, it's like going on a swing. If you're pumping your legs and your back and forth of your upper body at a specific time, the swing will go higher. But if you don't do that, then the swing will stop swinging, period. So once you understand the timing of the swing going back and forth, you start to understand that it's a specific time that you can pulse this energy and you'll get to a higher level of energy. And Nikolai Tesla describes this. It is usable, and scientists use this type of stuff all the time. So, yeah,
Yeah,
what we're
and
just talking about is energy management.
this guy saying, notice how he skipped the fact that he admitted there is no free energy in the pulse. There is no free energy, like no free energy. The energy is already stored, but the difference is in what is the speed that is being released. It's not the same that you release it yourself, that you get the help from the speed of light to release this energy. Because in this case, we're getting the help of the speed of light to release the energy. That's where the, you could say, the extra energy is coming from. It's from the speed of light. Because the speed of light is pushing the magnet, the magnetic field, towards the coil at a really fast rate. The only thing that limits the rate of speed is the air and the rest of the components. But
Let me ask you a question. If you have a battery, can you charge your battery at 100 amps?
well, yeah, I guess
You can charge your 12-volt battery at 100 amps.
that's a little bit too much, I guess. But I think you can
Yes.
do it, right?
That that's exactly right. It's too much. The recommended amps that they want you to charge your battery is at 20 amps at max, so you don't destroy the cell. That means what you start to see is the liquid in there starts to boil off, and you'll start seeing the steam or the smoke coming out of the battery. The Because you're actually damaging the battery. Now, with that said, if my battery has 100 amps and I can only charge it at 20 amps, can I release more than 20 amps off the battery at one time?
Yes, you could with this collapsing field energy.
So would that be called in the frame that I stated, wouldn't that be called that I can have more power coming out of the system than I can put into the system?
Yes, power. Yes.
Okay. So I try to describe this because with that terminology, if you use it correctly, there's a lot of other systems that's stored energy, and then you have stored energy that you can take off more for a small duration of time, energy than you're putting into the system. So when you're doing this and you understand what you're doing, then that
Right.
means that if you have multiple batteries and you want to double the energy, because you can only put so much energy into it, then it all results to time related. So
Exactly. Exactly.
this is how I came up with the theory of over unity, and I'm talking about the dictionary words over plus unity, using it from the dictionary, what those words mean. And when you use it in the correct terms, they never wanted this out of there because what happened is that I can keep running my systems and putting a battery in a water wheel simulation, and then the energy that is going into a battery, you're pouring that same energy out. And if you do that fast enough, that means the switching between the two, it seems like you have infinite energy, even though it is coming from stored energy. So I
Yes.
have,
Yes.
yeah,
Let's go back
we
to
can
it.
do that with capacitors too.
Yeah. Let's just go back to it real quick. I just want to show that one more time. Okay, I'm sharing my screen, right? You guys can see it.
No, I can't see it yet.
No, not me.
Sharing your screen. Okay, now.
Yeah.
Yeah, yeah,
Okay. So let's just go back to it, because this amount of work that is being done in the 33 microseconds in this pulse, it was just one pulse. But what happens if you could pulse it a lot of times with a device like a MOSFET in this case, as you have mentioned? The MOSFET can turn it on and off, on and off, on and off. So this cycle that we just talked about can repeat, and we can be continuing to generate this and even more power, probably a lot of more power. So the power, yes, it's growing, the power, but as you can see, this is telling us that the energy is conserving. It's only 5 joules, but the issue comes uh, when you are releasing that energy in such a small amount of time. This
right.
is giving
E
you
over
more
delta
power.
times time.
Notice how it's not giving us more energy. It's giving us more
Right,
power, but it's not giving us more energy. It's the same
right.
energy released in less time.
Yes.
Yeah. So that's where everything matches, and that's why we need, like, the, as you said, like the pulse. This is only one switch, one switching. When we can keep doing that all the time, like in a way to generate the sine wave.
Right. And this is what your MOSFETs do if people don't understand.
Yep, yep. All right, guys. I just wanted to show that, but I have to fly right now. But
Okay.
thank you.
Thank you.
Thanks for sharing.
Yeah, yeah, yeah. Thank you, guys. We'll keep in touch.